Linear inequality in two variables review. Okay, this is an Algebra 1 skill. Okay, I took this out of the Algebra 1 textbook, but we're going to be building on this skill in Algebra 2, so I think it's important that we review it for those of us who may have forgotten or didn't either have this in Algebra 1 or didn't learn it well in Algebra 1. Okay, so our objective in this lesson is to be able to solve and graph linear inequalities in two variables. So first of all, we talk about what is an inequality. Well, our inequality symbols, our inequality symbols are the less than, the greater than, the less than or equal to, or the greater than or equal to symbols, okay? So it's saying that two things are unequal, okay? It's telling us which one's bigger than the other, okay? So when it comes to solving an inequality, inequality, okay, again, we're just looking for which numbers are bigger or smaller, okay? So to start here, let's just look at solutions. Let's ask ourselves, is -1, 9 a solution of this equality? 2x plus y is less than -3. So what we're going to check to see is when I put these numbers in for x and y, do I get a true statement? Okay, so let's put those numbers in for x and y. So I'd have 2 times -1, that's my, again, there's my x, there's my y, plus 9, do I get something less than -3? Okay, so 2 times -1, that gives me -2, plus 9, is that less than -3? -2 plus 9 is 7, is that less than -3? 7 is not less than -3, so no. -1, 9 is not a solution of that equation. Okay. All right, so let's do another one. Is 2 -2 a solution of this equation? So again, we're looking to see if I put these into this, will I get a solution here? Okay. So let's see, we'd have x is 2, so 2 minus 3 times y, which is -2, greater than or equal to 8. So 2, that's a -3 minus 2 gives me plus 6. Is that greater than or equal to 8? Well, 2 plus 6 is equal to 8. So yes, it works because of that equal to component. Okay, so that is one solution for this. Okay, like this equation has many numbers that work. For example, I can see that the number 2, -3 would work. Because when I put a 2 and a -3 in here, I would have 2 minus 3 times -3. Is that greater than or equal to 8? Ooh, out of room over here. Well, that would be 2 plus 9. Is that greater than or equal to 8? Yeah, that's 11. Is greater than or equal to 8. So then the point 2, -3 is a solution. The point 2, -4 would work. 2, -5 will work. Okay, linear inequalities. Again, this is linear because it has both x and y, and their degree is 1. Okay, the biggest exponent is 1. So what makes it linear is that the biggest exponent is 1. So you have an exponent of only 1. Okay, but linear inequalities have many, many solutions. There are infinitely many solutions. So to denote these many solutions, we use what we call a graph to show you what all of the solutions are. Okay, okay, does that make sense? Right. So if we want to, there's 3 main steps in graphing a linear inequality. First, you want to graph the boundary line. So basically, you want to graph the line. Use a dashed line for strictly less than or strictly greater than, and use a solid line for less than or equal to or greater than equal to. So the solid line means that we can equal that point. And then we want to test a point. We want to test a point on one side of the line, one side or the other, and then shade in whichever direction. Okay? So, all right, so let's go ahead, and I think the easiest way to work through this is to actually look at an example. Okay? So let's go ahead and let's look at the example. Y is greater than 2x plus 6. Okay? So this is already y, is already on this side all by itself. Okay, so I want y to be greater than 2x plus 6. So I'm going to graph the equation y is equal to 2x plus 6. So I'm going to graph that. So I need to So I'll have to remember how to graph lines. Okay. So from this, I can tell this is my y-intercept of 6. That's my y-intercept. So it's crossing the y-axis of 6. 1, 2, 3, 4, 5, 6, right there. So there's a point on my line, and this here is my slope. My slope is 2, so I write that as 2 over 1. So rise of 2, run of 1. So my line is going to look like this. Okay, so graph the boundary line. Now use a dash line. This is a strictly greater than. So since it's greater than, I want a dash line. I always use pencil to graph, and then to dash, I just come in and I erase pieces. That to me is the easiest way of making a dash line. I just erase pieces. So there's my dashed line. Okay. Okay. So then this line is all the points that are equal to this thing. But I want my y greater than 2x plus 6. So my second step is to test a point. Pick a point, any point you want on one side or the other. Okay? So I'm going to pick a point either above the line or below the line. So I'm going to pick a point below the line. I'm going to pick 0, 0 because it's below the line, and 0, 0 is an easy point to use. So I'm going to pick the point 0, 0. And I'm going to test it. I'm going to see if the point 0, 0 actually works in here. So let's test it. So we're testing our point. So if x is 0, y is 0, so 0, is that greater than 2 times 0 plus 6? So 0, is that greater than 2 times 0 is 0 plus 6? Is 0 greater than 6? Nope. It didn't work. So I know the point 0, 0 won't work. So I know none of the points on this side will work. So that means the points on this side must be the points that work. So then I'm going to shade above on the opposite side of that line because the point 0, 0 didn't work. So all of these points that I've shaded are the points that will work, that will make this thing true. If you're not sure, try one. Let's see, negative 1, 2, 3, 4. Let's use the point negative 4, 0. And let's plug it in there because negative 4 is on the shaded side. So negative 4, 0. So y, which is 0, is greater than 2 times negative 4 plus 6. 0 is greater than 2 times negative 4 is negative 8 plus 6. 0 is greater than negative 2. 0 is greater than negative 2. Yep, it worked. Okay. So all the points on this side of the line will work. And since it's a dashed line, the points on the line itself won't work because that'll make it equal to. And we want to be strictly greater than. Okay. All right, let's do a few more examples. Okay. So again, we want to graph these. So the first thing I need to do is, again, graph the boundary line. So first make sure, is it y on one side? Yep, so I'm going to graph y equals negative 1. So I'm going to graph that line. Okay, so I'm going to graph y equals negative 1. So I take my y-axis, it crosses down here at negative 1, so it's going to be this horizontal line. So here, so it's going to be this horizontal line. So there's my line, right there. Okay, and now I want to look, does it need to be dashed or solid? Well, it's strictly greater than, so that's dashed. So we're going to come in and we're going to dash it. So there's my dashed line right there. And now pick a point. Okay, so let's pick a point. Let's pick this point here, point 0, 0. So we want to replace our x's and our y's. Well, there's no x's, so I don't have to worry about that. Replace my y with 0. So 0, his y was 0. 0, is that greater than negative 1? 0 is greater than negative 1, so that, yep, it worked. Yes, it works. So that tells me I'm going to shade on the side with that all the way down to my line. And lightly shade. Don't shade too solid in case you shade wrong and need to come in and erase it. Okay, so any point up here will work in this inequality. Okay. All right, let's do the next one. Ooh, this is an x. So my x is all alone by itself here. So again, my first step, graph the boundary line. So since there's no y in this problem, I'm just going to graph x equals negative 4. let's go ahead and let's graph that line. Okay, so x equals -4, so let's come here, it's my x-axis. We cross at -4, 1, 2, 3, 4, right here. So it's going to be a straight vertical line. There's the line, x equals -4. Okay, now look, is it dashed or solid? Well, I'm less than or equal to, so that tells me it's going to be solid since I have the equal to component. Okay, and then we test a point. So again, let's come over here to test 0, 0. Do you notice I always test 0, 0? You don't have to. You can test any point you want, but zeros are easy to put in. Okay, since this doesn't have a y, all I need to do is look at x, so 0. Is 0 less than or equal to -4? No, it's not. 0 is not less than or equal to -4, so I can't shade on the side with the 0, 0. I'll have to shade on the other side, so we shade over here. So basically, any point on this side of that line, including the points on the line, will work in this inequality. Okay. All right. Okay, so now let's go ahead and we're going to step it up a little bit. We're going to get away from the horizontal and vertical. Okay, so this next one is x plus y is less than or equal to -4. So my y isn't on one side by itself, so I need to get it that way first. So I need to isolate the y. So right now it's x plus y, so I'm going to subtract this x to the other side. So we'll have x plus y minus x is less than or equal to -4 minus x. X minus x, so because it is a positive y, is less than or equal to. Now if we rearrange this, it's going to be -x minus 4. Okay, so let's go ahead and let's graph it. So we're going to graph, we're actually graphing the line y equals -x minus 4. So this has got a y-intercept of -4, -1, 2, 3, 4. Ooh, good thing I didn't go down any farther. That's where it crosses the y-axis, and a slope of -1. So it's going to go, down 1 over 1, which puts me about here. So if we go the other way, back 1, up 1. So my line is going to look like this guy right here. Okay, there's my line. Now, is it solid or dotted or dashed? Dashed, let's see. So it's equal to, okay, so it's equal to, so it's a solid line. So we can go ahead and leave it solid. And now we pick a point, see if it works. And check it back in the original equation, okay? All right, so let's go ahead, let's pick a point. I'm going to pick the point over here. Let's pick the point 2, 1. And I'm going to see if it works. I'm picking the point 2, 1. So I'm going to put a 2 in for x, a 1 for y, see if it works. So 2 plus 1, is that less than or equal to -4? Okay, so 2 plus 1 is 3. Is that less than or equal to -4? Nope, it didn't work, so I can't shade that way. I'll have to shade on the other side, which is down here. So we'll shade the opposite side. So any point on this side of my inequality will work. Okay. All right, 3 more. Okay. Y is greater than -2x minus 4. So we're going to do this very similar to the last one. Again, we're going to graph the line y equals -2x minus 4. Okay. So it has a y-intercept of that -4, so down 1, 2, 3, 4, and a slope of -2. That's my slope. So it'd be -2 over 1, so we'll go down 2 over 1. So my line's going to look like this guy right here. Okay, now solid or dashed. Well, I'm strictly greater than, so that's going to be dashed. So dash it up. Okay, and then now again we test a point. So again, you can test any point you want. Let's come over here. Here, let's test this guy right here. That's over 2, up 0. So let's test the point 2, 0. Okay, so let's put a 2 in for x, a 0 in for y, and see if it works. So 0 in for y, 0 is greater than negative 2. A 2 for my x, minus 4. 0 is greater than negative 4 minus 4. 0 is greater than negative 8. 0 is greater than negative 8, so yes, it works. So I'm going to shade where my point is, because it can include any of those points over there. Okay, and again, you can check as many points as you want to make sure it works. Okay, but any point on this side of this line should work. So the point 0, 0 will work, the point 1, 1 will work, the point negative 1, 1 will work. Any point over here will work in this inequality. It will make this statement true. Okay. All right, so now let's go on to number 5. So first things is, again, this is a lot like our example 3. I have to get my y on one side by itself. So let's go ahead and let's subtract this 5x from both sides. Okay, so I have negative 2y is less than or equal to, if I flip this around, negative 5x plus 6. But now we need to divide by that negative 2. Okay, but here's where we have our one issue with inequality. So this problem is important. I just divided both sides by a negative, which means I now switched the sign of both sides, which means this guy has to get flipped. So it's going to be y. So now this is going to flip greater than or equal to. Divide both of these by the negative 2. So this would be 5 halves x minus 3. Okay. And so then now I need to graph this. Oh no, I'm out of room. Okay, so let's go ahead. Let's cross out number 6. We won't do number 6, and we'll just graph number 5 over here. Okay. So this now, I have y is greater than or equal to 5 halves x minus 3. Okay, so now we want to graph it. This crosses my y-axis at negative 3. There's my y-intercept, so down 1, 2, 3. And it has a slope of 5 halves. That's up 5, 1, 2, 3, 4, 5, over 2. 1, 2, 3, 4, 5, over 2. Always do a couple points to make sure I counted right and make sure they line up. Okay, so there's my line. Now we double check. Does this line need to be solid or dotted? Well, I'm less than or equal to. I've got that equal to component, so it's solid. And then now we test a point. So let's see, let's test a point. Let's test the point 1, 1. That looks like a good point. So we'll test the point 1, 1. So I'm going to put 1, 1 into here for my x and my y. So let's 5 times 1 minus 2 times 1 is less than or equal to 6. 5 times 1 is 5. Minus 2 times 1 is 2. Is that less than or equal to 6? 5 minus 2 is 3. Is less than or equal to 6? Yes, it is. So I can shade on the side with that point. So we're going to shade over here. So any point on this side of this line will work in this inequality. Okay. All right, so now you have, let's see, 6 your turn problems. Okay, so again, I want you to do these 6 your turn problems. Your turn problems 1 and 2 are very similar to my example 1. They're either going to be yes or no, the point works, or it doesn't. Okay, and then 3 through 6 are going to be very, very similar to the ones I just did. For 3, you're going to come and look at my example 1 right here. Okay, for 4, you're going to look at example 2. And then for 5 and 6, come back and look at my example 5 and my example 3. Okay, they're very similar. So you're going to have graphs and you're going to have some shading. Okay, come to class with questions, ready to discuss.